Hello, everyone. Let's get going. Anybody want to talk about what they were able to get done last week?
Hey, hey guys. Yeah, so I've been able to recreate those wave nets, those efficient nets by Diort. So I've been trying those deep neural networks with uh, uh, cat boost too, with some parameter changes, and I will be trying them this week too. So been trying to experiment with those deep neural networks and trying to figure out what works best on my local machine. So I was busy with that stuff.
Steve was saying he can't unmute. You were able to unmute, right?
Yeah, I'm able
And
to unmute. Maybe you should rejoin.
I am also. Can you hear me? Can you
Yeah,
hear me?
Benito, we
yeah,
can hear.
yeah,
Okay,
we can
then
hear
it
you.
works. Okay, good.
Yeah.
Especially Steve,
So
maybe. Yes,
the host isn't allowing me to unmute. Okay. I know, even though I had that power. Let me see. There is do anything different when I logged in right now. I guess Steve is trying to rejoin. See whether Yuri, can you try now, Steve?
Sorry, can you say it again?
Unmute. Oh, so you were able to unmute too. No, Steve said he couldn't unmute and couldn't join, but others are able to. So I was just puzzled why he said the host was not allowing him to unmute. But let's see. Everybody else is able to. There is Steve.
Yeah, my Zoom client had updated. Yeah, so like it wasn't. It was going through the new Zoom client, and it wasn't allowing me to unmute, and it said that you were blocking me. Yeah, so I've joined through the browser, but seems okay like this.
Yeah, so, I mean the others are able.
What you were saying, really?
Speak. I didn't even know I had that power. Like,
you don't know how powerful you are.
Yeah, like I can do that.
Yeah, I'd never had it before. As I say, it must just be something to do with my new Zoom client that had updated.
That's funny because everybody else was able to, and I was like, I don't even know which button I would need to push to be able to do that. But
yeah, I've never had it before. So
yeah, the updation might have messed up the permissions.
Yeah, I need to check my settings. But yeah, so sorry, Mike, I missed what you were saying about your progress.
So I was saying that I had those XGBoost by there was a notebook by on XGBoost classification and it's hyperparameter sweep by Andreda. I tried that on my local machine. I experimented with those hyperparameters and what should be the optimal one for an XGBoost model. And then I experimented using the WaveNet one, the old, not so old, but the Chris Diod notebook. So I'm trying that. The next is the efficient net ones. So there's all these notebooks that I have in my queue that I have to try. And yeah, I've been trying to experiment with them and getting to know the data sets with the overlapping and stuff. So Yeah, I've been trying with that tabular data and trying to experiment with those notebooks and such subtle variations. So with the RESTnet one, I have to try with the various the depths of convolutional neural networks, and to see where I can fit my score to, where I can reach my score with trying out different parameters too. And yeah, so that's the stuff I've been doing this week.
So I had a question, Steve. The thing there were a few things that were kind of puzzling for me. The discussion we had of just submitting the per row numbers just to see what the score would be.
Yep.
If you recall, the per row would be, instead of grouping by EED or by spectrogram ID, just kind of do a per row so that it's every slice of the EEG ID gets its own stuff.
What's per
And
row here?
Sorry?
What's per row here?
So as I was just saying, per row is just taking every row as a data point instead of grouping by spectrogram or grouping by EEG ID. Right?
So you mean to say every 30 minutes of I think so that's the main part
every
of
50
the
seconds.
Yeah, the 50
So every
seconds
50
of it.
seconds of the
Yeah.
EEG. So every
Mhm.
50-second EEG is a data point by itself.
Okay.
That has obviously the votes, and you just do that and you kind of calculate the proportions and you submit that. But the strange thing is that submission never, and I just followed your notebook, Steve, of what to, as calculating equivalent to the kind of all vote shares are equal kind of approach, right? Just make every row of the EEG ID have the same proportion of seizure votes, LPD votes, and so on. So for example, let me share here for a minute. You folks see it now?
Yes, you can see it.
Yep.
It says submit per row, right?
Yes.
Yep.
Yeah, so all I was doing was this, so that, it just read it in and then calculate sample submission and same stuff. And then I took the predictions, the values that you get by just doing the rows that I calculated, and I did this. And now the interesting part is that none of these submissions would get scored. Do I go to the submissions stuff?
If you go to the competition on the left hand side, go. Oh yeah, and then pick HMS.
Oh, yes.
Oh, yeah. So pick HMS, and then submissions there.
Okay. There's submission. Okay. Right. So if you see here, I couldn't get any of these to score.
Where's your submission loop?
I
Can you click on that so we can see the logs there?
I thought, maybe it's the EG ID, and I kind of fix the type of it to be, and it gives me the correct one. I just did this, and then, write it out as submission, and then obviously I go to the submit file and submit this. And it wouldn't, the first time I was in, the internet was on, and I fixed that, and, then I was wondering whether these are the correct format, and yeah, they turn out to be FP32. That's, it automatically takes that, so that's fine. And then there was some issue as to whether this was correct type, so I fixed that, and then I get the output and I submit. And this just simply, this doesn't want to score. Now I forget. See.
Yeah. Can you have a look at my notebook, my public notebook? Yeah, because I do the same thing in mine. Just hard coding the values.
Right, exactly. That's where I kind of. Yeah, that's the one, right?
Yeah, so just at the bottom of that.
Yeah, that's what I exactly followed, right? This is exactly what I did. So I just took the threads. As you can see, my threads are different from yours. Right, threads, and then did this, and then do that, which is exactly thread blah 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 df, and write to submission, and then I submit. And thing just doesn't.
Oh, is it maybe? Have you got code up above or something that's maybe crashing before you? You have other code in the notebook, don't you? Before.
No, in fact, originally I did, but then I kind of removed all that. So all I do is just simple. I was just figuring out. So this is import. This is just train df head. And then that's just to find out the data type, and then everything after that is just submission. So I just do the subtier.head, SDF, then the threads, and TFEG is as type, then DF, then submit. That's it, about 5 or 6 cells. And for the life of me, I was like, okay, I'm just going to pick up on it. And as Mike said, I don't know that there's anything here, Mike, that you can catch.
Yeah, there's nothing specific here for us to.
Yeah, like normally in the submission, if it fails, it doesn't really give you much information.
Yeah, so I was just going to request if any of you can also, just because it's so simple, if you can try it and let me know or post in Slack as to, I'm doing something stupid that I haven't caught. If it works for everybody else,
we could try making one now. If you just go to competitions, go to code, and create a new notebook.
Just create a new one.
Well, no, like you would need to go to click on HMS, click on the competition. Yeah, click on code. And then on the right-hand side there, click new notebook. Yeah, so if you go to my notebook now, just the bottom of it, and copy the cells.
So this one, right?
Yeah.
Do we need anything to import? No, right?
Well, if we take that one to
of
start
course,
with.
I'll have to add the data. But
Yeah, well, no, the data gets added, but because of the fact you did a new notebook from the competition, it'll have added the data for you.
okay. Okay. So that.
Yeah, so if you just.
I do that. Now,
Yeah,
instead
so
of the price being this, I just want to submit. Just want to make the threads be that, correct?
yeah, well, you can maybe leave the preds as they are for now, just to. And then, yeah.
Okay. Let me
yeah, back
then, in which case,
well, back.
let me just.
Yep.
That in there for now. Okay.
And then back in my notebook, you need a couple more lines.
Yeah.
Yeah, so you need that one. I think there was. Yeah, could you just go back to my notebook a second? I think there was another. Is there a line in between that's putting it into? Oh no, that's it, is it? Yeah. I'm sorry, I thought I'd seen one where it was putting it into int64. Or maybe that was the bottom thing, is it? Afterwards.
No, that was mine that I did.
All right.
Now that's it, right?
Yes. Well, we need to put the import for pandas in.
Okay, yeah. There. That's it, right?
On the right hand side, we need to turn internet off.
Do we need the accelerator?
No, there's no GPU being used.
Because we're
Yeah, so
doing it.
yeah, so if you just run all of that just to check it, it's okay.
It was so simple. I was like, I can't believe why this thing is on as a sub. Did you you submitted your notebook?
Yeah, we're missing something here. We need to import the test data frame.
Reading the test DS, right?
Yep. Hi. Yeah, so if you just hit run all on that. Oh yeah, sorry, we need to import
because you need to import the submission file.
Yep.
It works, right?
Yeah.
Okay, so that works. Do I do a save, run all submit?
No, yeah, so just do save now. Shouldn't take very long to save.
Yeah, it's just.
Yeah, so
Like
when this.
I couldn't figure out.
Yeah.
Why?
See see like it's successful now.
Okay.
I would click on the three dots to the right there, and then open in viewer. Yeah, so that's opening your saved one. Then I go to output
Then go output, right?
and then submit.
Yeah. Take a while, I guess. We'll
Yeah, like
figure out.
it's a bit longer, so it took a couple of minutes, that one. But yeah.
Yeah, it might take more than that.
But yeah,
but
so
it's kind of. Go ahead.
yeah, I don't really see anything different in that than what you have, but there's maybe some peculiar thing. So
yeah, no, I was. So you did submit whatever you had, and you got a score.
yeah. Yep.
Interesting. Yeah, because I didn't know whether you can. Okay.
There you go.
Now it succeeded. Wow. So I don't know what the heck I was doing wrong with mine. That maybe I should just remove the other stuff and see what. That's really puzzling because my stuff here. Maybe the fact that I was fiddling around with the data types it didn't like or something. And I did it because I wasn't sure whether it was giving, see the string of row and was complaining something. So I did something different with that. Maybe that's why. Oh, no, wait, that's because, okay, hang on. We haven't quite done with the experiment. I have to change the, to declare success. Need to change this.
Yep.
This. And do a save. By the way, one reason initially I thought of that it was potentially causing the problem, just so that others can, be aware of this as well, is that these numbers need to sum to 1, right? Because they are proportions. So I did check, and it's like 0.99999 something. So, that's another potential reason I thought of that it could fail. If the sum of these numbers is not 1, then that's a problem too, because they say that it should sum to 1.
Yeah. Can we take a look again quickly at your notebook?
Sure. Should I just run this meanwhile?
Srinivas, there is a function that has in some notebooks. I mean, just to be sure that the sum of the probabilities is 1. So you can also implement this at the end to be sure you have a 1.
Okay,
Yeah.
okay. Yeah. Thanks.
Yeah.
Yep. Got it, Benito.
Yeah.
Yeah.
So you can
So
just do like a check at the end. Yeah.
Right. Yeah. That'd be a good thing to include here. But I did check, and it's like, the 7th decimal or something, 0.9999 something. Sorry, Steve, you're saying looking at this?
Yeah, just on your notebook. Yeah, just below that. Yeah, here you've cast the thing into int64 before you've submitted. Yeah, so I don't have that line. See, yeah, see like line number 7 there, where you've turned the EEG ID into an integer 64 before you submitted. Yeah, so I don't have that. So that's maybe what's caused your problem.
No, I added this explicitly because I was wondering whether that, originally I didn't have this in one of my earlier versions, and it still failed. So then I added this. I mean, it would be easy for me to remove this and submit to. I checked what type it was, and because here you're converting it into a string, I thought. So, right? Because you're kind of making this in order
Yeah.
to add these
Yeah,
to
so
lists?
here you've turned the GID into a string, and then you've turned it back into an integer 64.
Right.
Yes, I think that's your problem.
Whereas the reason for that was I checked what it was here and it was an int 64. So I thought, okay, maybe that's the problem. And that's why I added this line. Originally, I didn't have this line.
Yeah. Your other notebook's just finished saving there, so you could submit it.
Ah, okay. And maybe, it may be that, as Pinky was saying, maybe I need to do this that language checks for 1, and if it's even 0.9, 0.0000, whatever 1, or it's off by, then it kind of gives that issue. But that's weird because my proportion generating stuff gave me those exact numbers without me futzing anything. Yeah, see?
Oh. Yeah, so what do if you go to your thing and add up your scores, what do they come to compared with the scores I implemented?
Yeah, so let's see.
Well, you can just use a notebook cell here, can't you? Just in the cell, yeah, like if you run that. And what is it?
Preds.sum, right?
I think so, if you can sum up the list.
Yeah, I think so. No, am I?
You can stick NumPy array around it, I think. So if you type np.array, then open bracket, and then put preds inside that, and then do .sum, I think.
Oh man, this drove me nuts for about 2 days. I'm glad I'm not off my rocker.
Is there any other?
I mean, if it, sorry, the other preds?
No, just you can try my preds and see what mine add up to.
Yeah, sure.
Well, no, like just uncomment mine and.
I'll just call it something else. That.
Yeah, so I have no idea.
Yeah, and this was frustrating because it's the same thing that happened to you in the last competition where, when you submit and it just fails on the scoring, it doesn't give you any ability to debug. And I'm just like, this is going to be painful. I couldn't figure out, and I was just like, why? I mean, and, like you saw, it's not doing anything different. It just fails. Like, anyway, don't know that we need to solve the mystery live, but definitely would, if anybody can think of anything and that I'm doing that's or that even it shouldn't work or any of this kind of, and as you just saw, I mean, you just saying the proportion and the proportions add up to 1. So that's not a problem. And it's the exact same code. So anyway, glad that it's not just my polar brain off in La La Land. That would actually have been good if it were something simple, but it's really not. I don't know why it fails. So, you know, the reason I wanted to do this was to make sure that, or at least get an idea from this before I did the per row EEG or spectrogram and use that in generate results. And I thought of something that I wanted to kind of, last time, Steve, you had mentioned that one thing to watch while doing this is the proportions could be different, right, of the seizure votes or things like that. But counter to that, the thing I was thinking of, the way Chris Diot or any of the other notebooks currently that are on public notebooks on top of the leaderboard do they do one of two things, right? Is when they do EEGs, they take the kind of the first EEG, if you will. Therefore, they drop out the last, whatever. If you use the first example, then the totality of the EEG, because the offset is about 40 seconds, if memory serves me right, so is about 40. So that means, you know, you would have from about 90 seconds, whereas they use, and I believe Chris does the middle, and some other people just do the initial, but they kind of take a slice, either in the middle of the 90 seconds or 50 seconds, or at the beginning. So it goes from 0 to 50, or it goes from 40 to 90. And they take that. And again, when it comes to the spectrogram, you know, you would have, because the spectrogram for 10 minutes, and if it's a 40-minute offset, then you would get a 640. That's why the spectrogram in the first case is of 320, because it's every 2 seconds, or a total of 640. And after 640, you could again take the middle, or you could go from 0 to 300 and just miss the last 20. But either way, you're taking, you know, EEG, a single EEG and a single spectrogram, and each of which has multitude of scores, which is the reason that, you know, you group by EEG and stuff. So my question is, if we did the per, or my comment or thought is, if we did it per row, right, so that every, and again, you could obviously do it for EEGs and do it for spectrograms, right, because each of them has their own offset thing, and you could create EEGs per row of 50 seconds. And I was thinking that that's actually a better training model for the training, because in the test, you get a single EEG and a single spectrogram. So it's not the case in the case of the test sample that's provided to you, that you would see a distribution of course, you still have to come up with a distribution of the scores, the 6 classes, but you are seeing a single EEG and a single spectrogram, right? So wouldn't it be the case that therefore, if your model is trained to with a single EEG and a single spectrogram, that it would be better, not worrying about the proportions? Because we can't guess the proportions in the test set, or in the private test set, in the public test set, or in the private test set, right? So does my argument make sense? Does it sound reasonable, or are there issues with it?
Well, the only thing I was thinking about proportions wasn't about the inference time, it was only at the training time. Because yes, like obviously the category that has the most is the general one, whatever it's called, the other vote.
Other.
Yes, like
Yeah.
and yes, some of the EEGs you have, they only have like 1 50-second window, whereas like some of the larger EEGs maybe have like sort of 12 or 14 windows in time. And so yeah, so what Chris Diot does at the minute is so like he adds up all of the votes for a single EEG and then averages them. So like that's the average score for that EEG, and then he takes a middle slice between the start offset and the end. Yeah, so like he's only training on one image per EEG as opposed to for every one of the offsets. And so yeah, like so say other vote has like a lot of EEGs with 14 windows, say, then suddenly the amount of other vote category that you're going to have in your training set goes up massively. And so yeah, you would need to watch with balancing it. But yeah, certainly, yeah, I'm not sure if some of the windows in an EEG start off with one type of votes and then by the end they have a different type of votes, or
they
across
do.
the
And
board.
I think I've seen discussions which says that they do, and that was the other reason I was thinking that taking only a single EEG would like help with that, or are you thinking that's a problem? Take a single EEG, because if you're taking the middle, for example, then you are missing out the part where they could be changing it because at the end of the day, isn't your goal to kind of predict on a single EEG and a single spectrogram, right? And in fact, that was the reason that the Seshuraj, when he was doing all these leaderboard checking, Chris was telling him to try and see whether there are multiple windows or multiple, spectrogram or EEG windows in the test, and they don't appear to be, although we can't be certain of that.
Yeah, I just thought, yeah, because of the fact he averages over the vote scores for a single EEG, and then because he's taken the average, he needs to take like a single window from the EEG that's representative of that average, and so yeah, he just picks the middle one, which is probably better than somebody who picks the first window because of the fact that the middle is probably going to be more like the thing. But yeah, certainly I don't think there's any reason why you just couldn't use all of the windows and just use their actual scores, or you could even slice the EEG up into your own windows, make them smaller.
Exactly. I was thinking that's another, which is, take the 10 seconds which matter in the EEG, right? So because this EEG gives you 50, every row gives you 50. And what matters according to the text is the middle 10 of the 50. So, and you could potentially for every row take the middle 20 and, of the EEG, and for every row you just focus in on the middle 20 or even the middle 10, because the middle 10 is what is actually being scored.
Yeah, I was wondering if you could actually slice the thing into the whole EEG, just like slice it into regular 10-second slices all across the board, even like the bits of the EEG that haven't been given votes at the minute, and like just find out sort of what the average vote is between the actual data points that you do have.
But then how do you give the title to the ones you're saying slice it into 10, but that I get, slice every 50-second EEG that you have into 10 seconds. And then for each EEG, you're saying take the average of the, so how do you come up with the labels for each of those 10?
Take the average between the 2 points. So say you've got like a single EEG image, and at the minute it's got 2 offsets in it, so it's got 2 rows in the training data, and you you wanted to take a window halfway between those 2 points, between those 2 rows. I was wondering, could you just average between the votes to get like a midpoint effectively? And so you create like a new data row effectively.
I see. So you're saying average rows and if you take the middle of the 2 offsets, which isn't that what you said Diod does? Because he is averaging all of the EGs and then taking the middle of the entire offset. So that's equivalent to what?
Well, no, but like that's what he's doing. But so for every single offset in an EEG, he takes all the rows for a single EEG and averages the votes. So you might go from like 10 rows in your training data, and then you average all those votes, so you only end up with a single row effectively. Whereas like what I'm saying is, rather than doing that where you're shrinking down all the rows into a single one, could you not go the opposite way and make more rows by averaging between the data points?
I see.
Or even like take all of the windows at regular intervals in the EEG and use the average score for the whole EEG as their target values.
Won't the overlapping EEGs, those point to the middle, near the middle where the main meat of the EEG is? I mean to say the main part of the overlapping, the thing that we looked at the earlier call.
No, it's not always the middle, right? That's the thing that I was checking. And of course, I was doing it for spectrogram, but you could put it, because the EEGs are shorter in duration, it's not as much of an impact when you take the middle. But it's still the case that, as we were just discussing, it's the middle 10 seconds. So if you take a 50 seconds and an offset is 0, let's just stick with the first example because at least the numbers relevant to it are still in my head. So the first EEG, for example, the very first, when you sort it, group it by EEG and pick the first, the one that Steve has done, EDA on and so on. It's like 0 is the first offset, and there are, I think, a total of 9 offsets, and 40 is the last offset. So if you look at that EEG as an example, then you have a total EEG from start to finish of 0 to 90 seconds. Okay, and there are 9 rows in that EEG. Now, if you take the first, let's just, to stick with the example that Steve brought up, let's just stick with the first and the last offset as an example, just to simplify. So the first offset is at 0. So that means that your first EEG width that you get the scores for, the votes for, is from 0 to 50, of which they tell you that what they are actually scoring is the middle 10 seconds of that 50 seconds of EEG. So that means you're actually scoring the EEG from 20 to 30 seconds. The first EEG, the first score corresponds to the score for the first row of the first EEG corresponds to the window between 20 to 30 seconds of that EEG. The last row of that EEG, which, remember, the offset is at 40. So the offset being at 40 says that your 50-second window starts at 40 and goes to 90. Therefore, the window that's being classified for the last row of the first EEG is between 40 plus 20. So it's between 60 and 70 seconds of the first EEG. So now if you take the middle of the first EEG, the middle of the entire EEG, that means you have from 0 to 90. So the middle 50 of 0 to 90 would be what? Is it from, you got 40. So you start from 20 and you go from 20 to 70, right? So when you do this, so that's what, as for example, Chris is taking, is what Steve said. He would be taking for the first EG, the slice from 20 seconds to 70 seconds. Now the thing, and I did this for spectrogram because I don't think that it's as critical, although it should be easy enough to do it for EEGs too. You can check whether all of the slices that matter, all of the 10 seconds that matter, show up when you take the middle between 20 and 70. And if you did it for the first example that I just rattled off, the numbers, then you will find that it actually does. Because remember that the first middle 10 seconds of the first slice is between 20 and 30. Since our slice, the middle slice, starts at 20, it does capture the 20 to 30. Similarly, the last slice, and I was just saying, is between 40 and 90. So if you want the middle 10 seconds, that is between 60 and 70. And since our middle slice of the first EEG is between 20 and 70, even the 60 to 70 slice is still present in it. I went through all these calculations. So by taking the first EEG's middle slice to be between 20 and 70, you're covering all of the 10-second slices in the entire EEG's offsets. So you've covered all of the 10-second slices by taking the middle 20 to 70. Now, what I wanted to check, and I didn't do it for EEGs, I did it for spectrogram, is by doing, because the spectrograms are bigger, by taking the middle 300 seconds of the spectrogram, are you covering all of the relevant slices? And I found out that you don't when you take the middle. There are about 3,000 some odd, like 3,700 or whatever, that, where you're not covering the appropriate slices. And the reason why that could matter is because your score that you're taking in the labels is the average of all of them, whereas you're leaving out the relevant slices, the relevant portions of the windows from that, right? So I didn't do the calculation for EG. I might, want to go back and do that to see whether by taking the middle, whether all the windows that are relevant are covered or not. Does that make sense? I mean, I was rattling off a bunch of numbers. So unless you have the numbers at hand, it'd be hard to follow through the details of what I'm saying, but you can understand kind of like by taking the middle of all of the EEG slices, are you making sure that the relevant 10 seconds that matter for every offset, for every row, is included in the middle chunk that you're taking?
Why is this the relevant 10 seconds only? I mean, we can also take 20, 30 seconds too. So.
Oh, that's what they tell you. I mean, we can take how much? We can take the entire 50 seconds, as we were just saying, right? But they tell you that the grading is based on the middle 10. The grading meaning the marking of the labels that are done by the doctors is based on that.
Mm-hmm.
So what they see in the middle 10 is what they have given the label, or let me restate it. The labels are based on the doctors observing the middle 10 seconds, is what I understand from what the data, what the write-up says. So does what I said make sense, Steve?
Yeah, I think so, but there's I don't see a reason why you couldn't sort of shift the window about around the middle bit. Yeah, to give yourself more examples, or just like augmentation or whatever.
Yeah,
So
yeah, that's
I like
what I
then
was
even
thinking. And of course,
even
you
at
know, the
the
proof is in the
even at test
Go ahead.
time. Yeah, so if you've trained it like
Mhm.
that, where you sort of pick a couple of windows around the midpoint and train on that, then when you come to test time, you could do a similar thing, like stick, like test time augmentation.
Mm,
So for each
interesting.
image, just stick it through the model a few times, just shift it about its point.
Yeah. So, I mean, in fact, my first step in going down the path of trying a per row approach was to just get a score on the per row. And that's why I did that. And, you know, that hit me in the face. Like, nope, I'm not going to give it to you. And I was like, what's wrong? Anyway, so if anybody can submit that and succeed or figure out what the heck is wrong with that submission. The other kind of interesting thing, just as a, oh, by the way, just before I forget, I'll bring up, and if you guys want to add to it, this is the, oh, I'm not, have I stopped sharing or am I still sharing?
You're still
Yeah,
sharing it.
Okay, so this is the common stuff that created and added what Steve had recommended as well. So if you folks want to, I think Benito sent me an email, but mine's easy, Steve, whether has Rachel on the call yet? If anybody wants to submit, edit, feel free to just share your email with me, and you know, as they say, I won't share it with advertisers and family, but want to edit, then I can open up the notebook. Sorry, the Google Drive link and stuff. Which led me to this question, Steve. So, did you use any of this cleaning stuff with the MNE before you were used?
Yeah. So this week
that useful?
I finished off going through. Like last week, I'd shared about some course.
Right. That this one, this neural data science thing.
Yeah, so like it's got one chapter specifically about EEGs. It's really good. Like it describes exactly sort of what they are and like the processing that you would go through to stick the bandpass filter onto it, and like like how you can also clean them up to remove sort of like sort of I don't know, specific noise or whatever that can get introduced onto it. So it's a really good course. And then that other thing, that brain decode thing, it builds on top of MNEs. So like the MNE, you can create like an MNE data object for each one of our EEGs. So you can take like the EEG parquet file and stick that data into an MNE object. And then once you have it in that
Actually,
object.
there I had a question, Steve, before you go ahead. So did you use, I mean, the only way I could find to convert, quote unquote, convert, but actually it seems like, you know, there was one notebook in the discussions that kind of shoved the Parquet file actually into a raw data and then use some standard montage or whatever, 10-20 montage or whatever to read it into an MNE. And I have a side humorous story about that, which I'll get to in a minute. But was that what you used, or is there any other code that you found to read MNE from Parquet directly?
No, so yeah, it's not reading it from the Parquet directly. So I read the Parquet into a pandas data frame, I think. And then from the pandas data frame into the MNE is how I was getting it in.
Read Parquet into pandas and then read it into MNE. Okay. If you, do you, I mean, is there a standard, the humorous part for me was, so I didn't in the MNE documentation see any way to read Parquet. So I did a Google search and I have bad or generative AI search turned on. So I said, hey, is there a way to read Parquet files into M&E? And, sure enough, this stupid bad tool came up and said, oh, and it just followed exactly what it saw on the M&E website and said, and, here, try this. And, so I said, oh, cool. There is a read Parquet or whatever, just like, many of the read formats that the M&E data site that you pointed to has. And I went ahead and tried it and said, there's none of this exists. And I was like, dang, don't follow what, generative AI tells you. It just stupidly points to things that are similar and tells you that exist. So then I was thinking, then I went on a search, and the only way I found was this one guy has a code in the discussion where he has posted where he actually doesn't convert, he has a read. So I was wondering, if you don't mind, could you share the part where you just read it, or is it just simply just converting Parquet to pandas and just reading the pandas?
Yeah, there's a couple
So
of
there is
notebooks.
a read pandas in M&E?
Yeah, I think it takes the data frame. Yeah, there's a couple of notebooks in the public Kaggle competition at the minute that use M&E and sort of use it to display. If you just go to
there
the
are.
public,
I couldn't. I just found one. So let me.
I think there's 4. Yeah, so if you just go to
Yeah,
the
there are
public
4, but I
notebooks for this
think
competition, but
version of code. Code.
yeah, code. Yep. And yeah, just type M&E in there.
Yeah, these were the 4 that there's a new one, but there were 4. I think these 4, of which the one that I found which actually uses is, I believe, here. So what he does when he does read it is.
Yeah, so that's what I do. Yeah, so like here, as you can see, it's reading the Parquet into Pandas data frame. And then from the data frame, it
So
gets
this
the
one
channel
is
names.
what. Okay. So this is what I meant by he actually creates the channel names, shoves that into the M&E, because if you followed that course, then the M&E data, the raw data, depending on when it's extracted from the machine, it goes the other way, meaning that M&E can actually detect the channel. But in this case, because we already have it, I guess we go the other way of telling the M&E what the channel names are, and then letting it figure out using this montage standard one.
Yeah, so I think like normally if this was being used with an EEG machine, the EEG machine would generate these M&E objects, and like it would set the channels, whereas here we're coming the other way. We're coming from like a pandas data frame or from the Parquet file. So yeah, we create the pandas data frame, which is the data, and it's got the channel names in it. So yeah, so the first bit there, the M&E create info, that there's just like setting up the info about the M&E object you're about to create. So yeah, like it's giving it the channel names, and it's like telling it what type is for each thing, and it's telling it what the frequency of the data is. So at that point there, you've created just an info object. You haven't created an M&E object yet. Then the set montage thing, that there's defining where the electrodes are on the head. So like that standard 1020, that there's like like the picture you see where it's all the electrode names on the head.
Yeah.
And then finally the raw bit is taking the pandas data frame data and bundling it with the info to make the final M&E object. So like once you've done that, then you've got the thing. So if you were to go down below, then you start using it.
This guy, right?
Yeah, so once you have that, then you can see like now, yeah, so you can see on the right hand side there the picture of the head. that shows the electrons. In this data here, you can see at 60 hertz. Yep. At the 60 hertz, you got the spike, which is the power spike, which is why you want to stick the bandpass onto it. So like once you have it in this format, yeah, like in this format here, then you can use all of the sort of EEG specific bandpass filters and like other sort of manipulation things that they have.
Right. So, so do you, when you create your EEG data, you're going through this process and kind of using some of the steps to remove the noise in the data before you take the EEG and convert it into spectrograms?
Well, I haven't made any spectrograms yet. Yeah, so but like then, as I say, I've started using this brain decode thing, which is based on top of MNE. So the steps for me are, yeah, so take the Parquet EEG files and convert them into MNE objects, and then give the MNE object to a brain decode data set. And at that point, what I can do as well, yeah, so for each of the rows in the training data that belong to an EEG, like each of the offsets, I can set it up so as it's got like the target values with it. So like when I create like this brain decode data set, I now have my input data and my output data. But the only trouble is it takes an awful long time to make, to convert. Here, like when he's just making a single MNE thing, it'll take a couple of seconds. But you can imagine, yeah, so like in our data, what, there's 130,000 Parquet files or something.
Right.
Yeah, and like that. And then when you convert it, giving it all these all the window points, when you make the brain decode thing. Yeah, so I found I divided the data into 5 folds and like went to make my data set, and it took me 8 hours for one fold.
Wow, 8 hours for a single fold, huh?
Yeah, and
So
that's just
like
making
20% of the data.
Yes. And then I can save that as a brain decode data set, but it takes me 20 minutes to read it back in. So yeah, I think I'm gonna have to give up on this approach. It's because of the fact when it comes to inference time, it'll take far too long to read the test data in. I'll have run out of time before I even get to stick it through a model. So yeah, I've switched away from this now because it takes far too long. So I'm looking now, like there's a couple of there's like somebody published a notebook. It's a PyTorch Lightning notebook about using the raw EEGs. So I think other people use different techniques of sticking the bandpass filter on them as opposed to using MNE. So yeah, it seems to be too slow.
Yeah, that seems, I mean, actually the other question I had, and I guess based on, I haven't looked at the brain decode stuff, but the other question I had was just going through the MNE stuff towards the, I don't know, maybe the last half or the last third or whatever of the MNE EEG discussions, he gets into this specific, and of course, the terminology he uses there is going to be different from what we commonly know as epoch, but he kind of talks about epoch and slicing up the EEG into epochs. And the epoch is kind of like a term for the window, and the window there that he's looking at is about, the epoch size is about a second or 2 seconds or whatever, because the relevant thing when in that context that he's looking at is more what are called these ERPs, or the whatever the event related potentials, I think the ERP stands for, which is more like, oh, does the person who's staring at the thing and there they are conducting some test, and when the stimulus is applied, so when the stimulus applied is where there is a marker, and that's just 1 or 2, but that model doesn't, I mean, there is somewhat of a similarity, but that model doesn't exactly apply for us, right? Like, because our window is 10 seconds wide, and it's not a stimulus-based thing. It's just the 10 seconds around when the seizure or one of these other things happens to a person, right? So I didn't find that that portion of the discussion relevant, and I was just curious whether you were taking anything from that and applying it. So that was my other question with regard to the
yeah, as you say, like quite often in all the example data, it is about like a single moment in time where something's happened. Yeah, like somebody's stuck their arm in there or something, and they're looking to see what the EEG change is like. But you can, within the brain decode thing, you can specify amount of time before the event and amount of time after the event. So like that's what I was doing, and I was taking the event as the center of the 10-minute window that we've got the votes for, and then like I was taking 5 minutes before that event and 5 minutes after to make the 10-minute window. But as I say, I think I have to give up on this approach and go somewhere else.
Yeah, too slow. Okay, I'll check out this PyTorch Lightning thing as well. Or if you have a link to that one, if you could post it. The other thing which I just out of interest for people that I wanted to point out, because there's this set of notebooks that this person has, Unit 6, will be blah blah blah, and he uses RESTnet 34D, does a 512 by 512 training baseline, which means he just does an 80-20 split in this notebook, and then goes on to do it on a 5-fold, and then he combines all these 6 things into models and submit that. Interesting thing is, I did exactly the same notebook. Now, of course, there is some randomization. I kind of changed. He has a lot of comments in this Chinese, but anyway, I translated as whenever it's relevant, and I used exactly the same seed, blah blah blah, and I kind of did my own version, coded. Also, he does this weird thing here of a long way of generating the the train features, but you can do this much simpler if you follow what Chris Diot does to get the proportions. So I did all that, but to make a long story short, the interesting part to me is using the same seed, and of course there is some randomization on how he does the split, because he uses some randomization within that. But the interesting part, just wanted to highlight, is following the exact same thing and just doing everything in my code. The scoring changes by as much as his scores that he got on these notebooks was, and then he eventually does the fusion of this spectrogram based and the EEG based, and his score ends up at around 0.42, and mine ends up at around 0.45. So there's like a 0.03 difference even with exactly the same code. And I still haven't quite figured out why that's the case. Because I don't do anything different than what he does. It's just, and I use the same seed. And obviously there's a little bit of randomization in the choosing of the 80-20 split, for example, that could happen. But again, given that I'm using the same seed, I don't think that ought to be different either. So again, just mystery there. And eventually that leads to his fusion notebook, where, as I said, he just uses the 6-fold thing that I've mentioned, and then he uses 2 EEG models of 5-fold each. But again, he generates the EEGs spectrogram from the EEG and then weighs them. I did exactly all of these, just my code rather than his. And again, he ends up at around 0.42, and I end up at 0.45. So just a heads up that, if you do your own version rather than just run his notebook, which I didn't want to do because I wanted to be able to edit and add and subtract and stuff. So I coded my own. I haven't quite figured out why those distinctions. If anybody has any idea, post in Slack, or if you happen to try out, let me know. So some of the things, again, by the way, there is another person who just does mostly the same thing, or at least follows a similar kind of path, called Tamara, I believe. Let's see whether I can quickly find her into. So I haven't tried some of these ensemble ones, just worked my way through, and you can see that he has a 0.43 score. Mine turns out to be 0.45, so just a 0.02 difference. Just following exactly the same thing. So, and his score on the 6 models is 0.45 and mine is 0.46. Now here is the Tawara guy that I was talking about, and just he follows exactly the same kind of approach, but there are some differences, and I just wanted, because last time there was some discussion of what are the other things you could do when you're just following along. So the three, interestingly, this guy, I can never pronounce his name, Kaggle expert, Yunsuxi. So I'm just going to. So Yunsuxi, interestingly, does not do any grouping at all when he chooses the folds, which I thought was very fascinating, because he doesn't use the patient grouping, nor does he do any stratification based on the folds proportions. He just uses 5 folds and just splits them into 5 randomly. And the Tawara guy, this guy, so one of the differences is he uses a grouping by patient, which is what, by the way, Chris Diot does, and then he stratifies it by using the expert consensus. So that's one difference between these two guys. In case you decide to use any of these notebooks, I just wanted to highlight that. The second difference is this person, Yunsuxi, slices the EEG or clips the EEG between -6 to +10. Whereas I think Chris, as well as this Tawara person, clips it between -4 to +8. That's a range of data that you would capture when you take the log, and that's somewhat puzzling to me, because the -4 to +10, -6 to +10 is a larger range, as you can imagine, than what Tawara does, which is, and what Chris does, which is from -4 to, I think Chris even used +6. Do you know, or anybody recall the upper bound that Chris uses? not, anyway, you can check it, but that's another difference. And that one seems important, right?
Srinivas,
The
did you
question-
check the leaderboard of the code, the base score? Did you check that notebook from a guy called, how it is called, Codinul? The first, the one, if you sort out by public score, that one, the quick assembly, that one. Did you check that one?
This
Because
one?
I went through it this today, and what this guy, if you open it, can you open it? And you can read the first line, the red ones. What he's doing is he's taking the one from Chris Deote, and then he's taking the one from this Jun Shu Xiaozi, the one you were talking before.
Yeah, this is just an ensemble of ensembles, right? Like he's just ensembling two, because like I told you, well, actually, no, it is this insert series testnet 32 512 inference 6 model is itself an ensemble of 6 models. 5 models that he trained by splitting the, by creating the 5 folds that I just described to you, where he does not group by patient, nor does he stratify by the expert consensus. Whereas in this case,
That one, he's doing that, yeah. Yeah, exactly. But
yeah,
what I don't
Chris does,
understand is, what I don't understand is, why do you get a score like 0.43 in the Chris Dote, then you get 0.45 in the other one, and the guy is just doing a sum of the results dividing by 2, and the final score is 0.39. So that's it. I mean, maybe I don't see maybe.
Yeah, I haven't done one part. I just did, and actually his fusion, by that Ian Sitsui's fusion notebook does ensemble of his own spectrogram trained models, which is what these are, and EEG trained models. So that itself, remember that his score, if I recall correctly, I'm talking from memory, so I could be wrong off by a few points, but his own score of this is about, I think, 0.44. Well, we could check that.
It is just below. If you scroll down, that the score is in the same cell. The same
score
text,
is 0.43, right? And what this 0.39 guy is taken this notebook and taken Chris Diot's this notebook, and then just ensemble those two to get 0.39. So that's just an ensemble of ensembles. So basically you keep averaging, and because of the fact that there are some differences, as I'm highlighting, between what Chris does, and of course Chris is using, besides the actual specific differences, he's doing it on TensorFlow, and this guy is just taking the actual output of the two models and then just ensembling them. And I don't know whether he uses any weights. So it's just the fact that as you keep averaging things which aren't similar, then you tend to get better results. But I want to kind of even figure out what's the best, single set of models, if you will, or single approach that gives. And that's why I was highlighting the differences between the approach this guy was taking. And even here, you can see the basenet, the inference 6 model is 0.45. So if this is what he's using, then then the top guy in the public notebook is just averaging this 0.45 and this 0.43 and coming up with 0.39.
Yeah,
that's easy enough. It's just an ensemble of ensemble.
Yeah. So but right now I think these are the best notebooks, probably, right? Or the best approaches, the one from Chris and the one from this Shushu, or however it is called, this name. Probably these are the best approaches right now, publicly available.
Yeah, but the difference even between this guy Yonsutsi and Tawara, that's the one that I was highlighting, is, the clipping data, the grouping is slightly different. The other interesting part to me was just another detail to pay attention to. Eventually, I think both of them end up doing it similar, but let me take a minute to call your attention to something which is this guy does one good thing, which is simple enough to understand, but just a heads up on the details that I wanted, because I spent some time on it, so others could benefit from what I caught or learned. Just to share that, this guy codes his own scale divergence loss. You can see that he has just coded his own scale loss. You can see that he's not using any NN scale div loss and stuff, right? He just coded his own loss. And then, and this part is important, this comment, right?
Do you read Japanese?
Yeah, unfortunately, my Japanese is pretty weak.
ChatGPT can translate the whole notebook for you.
So you see, sum the losses in the first dimension, which is the number of classes direction. So that's what this dim1 does. And also, I'd like to highlight that T here is your data targets, whereas Q is your prediction. So you can see that because you take the log softmax of the Q along dimension 1. So, and then whereas P, so P is your targets and Q is your prediction. Okay. Now, the reason I point this out is if you were to use, so he just codes that and then he takes the sum or, you multiply the P and then the log of the two, and P you've already taken, Q you've already taken the log of, and therefore you take the log of P, which is your given targets, and multiply by P and subtract Q, take the, anyway, you can see what the calculations there are. But the reason why this is important or relevant is if you were to use, and I'll just use now, unfortunately, to see whether I can find some training notebook. Let's see whether he here. Okay. In this case, this guy, he uses the inbuilt, so as I said, he uses the groups. That was the thing I was calling your attention to, and the grouping, and then splits by expert consensus, and the grouping is by patient ID, which the other guy doesn't do. So attention to, yeah, see here, KLDiv loss, he uses the nn.kldiv loss. I close this.
I think if you just click off, then just click to the side of it.
Can you have so many notebooks open? Srinivas, how can you have your browser with 30 Kaggle notebooks open on the top?
I would like to go searching. Tab, edit. So the thing I wanted to point out was this scale div loss thing, where it defines his own, here he does this, right, where, and now the reason I wanted to point this out is here Y and T, if you use the scale div loss, just be aware that if you actually use the built-in torch scale div loss, then Y is your predictions and T is the target. And that order is reversed to what the guy's code does. But eventually, anyway, it all works out to be the same. So this huge chunk of code is identical to this guy's single line. So
Yeah,
just a
I
heads
wasn't
up.
sure about that as
That
well.
took me a while.
Also, within Chris Diott's notebook, he pulls Python code in for doing all this, for calculating that loss, and like his code's even bigger. So yeah, I couldn't figure out which was the correct one. Obviously, like this guy here is doing it in 4 lines. Chris Diott's doing it in a whole Python file.
Oh,
If
I
you go to,
haven't looked at
if you went to Chris Diott's one,
this one.
yep, and then click on input at the top. Yeah, there. And then yeah, see the Kaggle KL div. Yeah, if you expand that. Yeah, so I think it's that one.
It's coming
Yeah,
from the
so
competition, right? I think that was provided by the competition.
is that? I thought this is his data set.
No, I think the
Yeah.
competition provided a Python file
No,
for
this one is
right?
existing in Kaggle. I don't even know that the
Well,
competition
if you go to the
guys
top of that,
provided it. I think this is
yeah, if you click on Kaggle KL, if you click on the data set, yeah, click there. Yeah, and then click on the name on the left, to the left. Yeah, yeah, click there. Yeah,
he
so it was
created it.
Chris Diott created this.
Let's say the code came from Kaggle. For example, how to use. You see there the second line. You read the scripts to compute, blah, 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 and then say the code came from Kaggle. I think he copied because I was reading about this code. I think there was something wrong in the code, something was not working, and he just changed it a little bit.
All right.
I think something like that, but I'm not 100% sure. But it's not from him. I think.
Yes, I just couldn't figure out why he's got like an entire Python file to calculate the metric or the loss.
Yeah, yeah.
Whereas the
look at
other
that
bloke's
for a
doing it in a
second.
couple of lines. So I don't know, is there much
Yeah,
difference in the result it produces?
Yeah, see, he's doing the min and the max, right? Clipping. One, you see this, NP clip epsilon 1 minus epsilon?
Yep.
Right? So if you look at this guy, he does that.
P clip, P epsilon. Okay, yeah, the same, huh?
Right? So that's identical. Then, oops. Okay. Okay. Then, so the rest of it just seems, like data type conversion, right? Float D type, solution column as type. The only thing which seems to matter is this guy. Otherwise, this is data conversion. Then again, this is data conversion. Then this is just says non-zero indices. So in case you have any non-zero indices, right, that you set it to 0. So that seems to be checking for some boundary condition of having non-zero stuff, because that's what this line is also. It's just dividing by stuff that seems non-zero indices, and what do you do when you do that? And otherwise, he's taking the NP log, right? And then there seems to be a couple of knobs here, which the other guy doesn't have, of micro average and sample weights, which don't exist in the other guy's code. But if you don't care about micro averaging and like having weights, I guess another annoying thing about Kaggle is you can't move around in this thing, or unless you guys have found out a way out. Yeah, there. So here, you see micro average, sample weights, are weights and average. So if you don't need that, then I guess there'll be some code here for if there is micro average, then you come and you give it the weights. Otherwise, you just do the average of the mean. That's scaled evidence. Then the score is, yeah, see, this is the case of dealing with these exception cases, I think. And the fact that you do the sample weights. So if you don't have the sample weights and micro averages and stuff, then I don't think that the code eventually is all that much different. Yeah, it's the first part, because this code, I mean, other than this micro averaging and the weighting and the data flipping around, by that into float or not float, seems to be otherwise identical to this simple 4-line thingy. Because I spent quite a bit of time comparing this guy's 4 lines of code to, let's get the other guy go. To that, and eventually concluded that they were doing the same thing. This guy was just doing it a lot simpler. And most of this guy's magic is in this line of code. And the reason this is important is if you search, and unfortunately I don't have it here, if you go back and look at torch.nn.kldev, and maybe I'll just torch kldev. So if you look at torch kldev loss, the important thing, and the Tawara guy does use this, is he uses this reduction equal mean. And they say that the technical definition of scale divergence is met not by the mean, then I don't know why they make the mean the default, but anyway, is by using batch mean. So yeah, see. So if it doesn't return the truth, I will converse and please use reduction as batch mean. So I don't know why they don't make batch mean the default, but and the Tawara guy uses batch mean. But batch mean does exactly what this guy's code does for batch. It just is an inherent part of kldev if you inherit from nn.kldev loss. And because this guy doesn't, he does it himself, he has to do this part. So best I can tell, and I haven't mathematically kind of submitted numbers and checked, but I went through the code quite in detail, and I think as long as there aren't any missing data and other things like that, this code is identical to inheriting from here and doing all the stuff that Tawara does, or for example, what and Chris seems to do. Although I think the advantage of using the kldev Pi code from Chris may be the fact that if you happen to have weights and wanted to use micro average for some reason, then that gives you a couple more knobs to twiddle that doesn't exist in this code. So since I spent about day or so figuring out what the hell was. And I just wanted to understand whether it was similar or not. And of course, one test I can run is just replace this code with the Tawara guy's code and see whether I get the same result or not. I haven't done that, but that. So, what else have you done, Steve? I think you're at 0.42 or something, right? So
I haven't made a submission in a while because, yeah, just like the last week, I was trying to get that M&E stuff working, and as I say, it's a bit of a dead end. So I need to, yeah, go back and like look at the newer notebooks that have come in. So.
Yeah, actually, but you know, since we were discussing, so the grouping and the clipping, and the third thing, which you know is interesting in terms of scoring differences between the HMS Yunsuxi and the Tawara, where Tawara gets a better result with exactly the same framework, is also he does, meaning Tawara does single cycle LR scheduling, which this guy doesn't do. So, you know, some of the traditional good old fast AI kind of techniques of doing things, those need to come in. Of course, the score improves by fractions, but still, you know, in Kaggle, the fractions matter. So again, to highlight the grouping, clipping to a narrower range versus a broader range, and then LR scheduling. So those are the differences. So I haven't yet I just identified them. So I wanted to go back and incorporate these three things into this guy's notebook and see whether I get better scores closer to what Tawara got. So just something to keep in mind if you were to use this. I haven't yet also looked at Chris's code to see, you know, all the things he does, which could be potentially different and can be incorporated into the base notebook as well. Anyway, that's the playing around that I did last. Any comments or thoughts from anyone else?
Not from my side, I think. I need to go through these two approaches from these two guys, the other and the other Chinese one. Try to understand what they do and maybe try to get something working. It's not an easy competition for me, this one.
Yeah, but you know, we all, that's, you know, going through these notebooks, making the submission, understanding, and then that's we learn the quickest. I mean, we've all been there. 2 years back, we were all doing the same thing. And I arguably is still doing this. So don't feel easy or hard. It just gets easier over time is all I can say.
Yeah, that's the thing. You have to go deeper into the competitions and try to go step by step, try to understand things, and then the next one will be better. But this stuff, this electroencephalograms is not an easy thing to understand. It's not like you take the data set and you see the pandas that are friendly. Say, okay, that's good. 10 columns, I think everything is clear. It's not like that.
Any other questions or comments, folks? If not, thanks for joining and see you all next week.
Okay, cheers. See you next week.
See you.
Bye.
Bye bye. Thank
Bye.
you.